I need three-phase power from my benchtop here to work on some phase rotation meters. Now, I can use a VFD like this. This one here you can put in 480 volt single phase and you can get three-phase out, but I don't want to work with that voltage on my workbench here, so I made up a little three-phase generator. These are little micro three-phase brushless generators you can get online. They're about $7, and here it is here, and I can turn that on, and the leads light up. Now, in order to monitor this on my oscilloscope, you need to put up some resistors like this in this Y configuration, and the centers are all tied common here to and that's going to be the ground for the oscilloscope, and then the probes are going to go on these A, B, and C here, the three phases here. Now, they should be 120 degrees apart, and each phase, and because the generator is physically wound with coils that are 120 degrees apart. But on the oscilloscope, you can test your phase difference here by taking the time between the phases, this time here, and then dividing it by the period and multiplying it by 360 degrees. So for a 60 hertz signal, the time between the phases is going to be 0.00555, and the period is going to be 0.01666. And if you divide those out, you get 333 times 360. That's going to be 120 degrees. Okay, so on the oscilloscope we can test that. Now, it doesn't matter what the frequency is. It can be any frequency. These coils are physically 120 degrees apart, so these sine waves are always going to be 120 degrees apart no matter what frequency is. In fact, this one's at 224 hertz, but any frequency, these you're going to always have they're going to be 120 degrees apart. So in order to figure that out, we take here's our cursors here. We put our cursors right here at this point and this point here, and that's the time between the phases in milliseconds, and that's right over here, 1.52 milliseconds. Okay, now the period, they give you the period 2 here, and that's going to be 4.56 milliseconds. So if we divide that out, it's 0.3333, and then 0.333 times 360 is 120 degrees. So we know that these are 120 degrees apart. Now, since I don't have a 4-channel scope, I can't get the other phase in there, but it would come into here. And what I'll do is I can change the probes around and then see how move this over into this point here and make sure that I have all three phases there. But that's how you measure the phase difference on the scope, and this thing should work out fine for testing purposes, and it's just low voltage, 24 volts, and so that'll work fine. And like I say, it doesn't matter what frequency, the phase difference is always going to be the same. They're always going to be 120 degrees apart. Anyway, that's it. Thank you.